Hello everyone, and thanks for tuning in to this virtual prescribed burn workshop. My name is Sam Dame, and I will be doing the PowerPoint presentation on prescribed burning today. So the goals for today are to talk a little bit about other management methods besides prescribed fire, and that will actually be in a partner PowerPoint to this one that we'll post later. So this PowerPoint in particular is going to focus on prescribed fire, objectives, fire behavior, and then planning a prescribed burn. So thinking about your objectives and what you want to achieve from a prescribed fire is really important. So ask yourself some of these questions. What are you looking to do? Are you looking to thin your grasses or knock them back, control some woody encroachment, stimulate your wildflowers? Knowing the answers to these questions can really help you in preparing for a prescribed burn. So for example, burns during different times of the year can affect vegetation differently. A lot of times during that spring burn window, you tend to stimulate your grass component, whereas late growing season burns tend to stimulate more of that forb and wildflower component. So prescribed fire can be one of the most cost-effective methods for managing plant communities. It helps remove thick litter layer that has accumulated and kind of prevented some germination. It can reduce hazardous fuel loads, release nutrients and dead organic material, and it can also be a really good precursor to other management activities such as herbicide application or tillage treatments. It can also be really good at removing woody growth, but one caveat to prescribed fire is that it doesn't necessarily thin native grass stands on its own. So prescribed burns differ greatly from wildfires. Wildfires are accidental and uncontrolled. They can threaten lives and property and do great harm. But prescribed burns are set intentionally, considering the safety of people and property. They have an objective, they have a written plan, and they have control structures and personnel to help keep that fire under control. Understanding fire behavior is really important when talking about prescribed fire. So on the right here we have the fire behavior triangle made up of weather, fuel, and topography. And all of those things greatly affect fire behavior, and paying attention to them can help you better understand what a fire may do. So the first one we're going to talk about is wind. Fire behaves more predictably when wind speeds and wind direction are steady. The ideal transport wind speed, which is measured at about 20 feet above the ground level, should be between 6 to 18 miles per hour for good smoke dispersion. And that ideal transport wind speed measured at 20 foot is typically what your weather station is going to forecast for you. And then the preferred surface wind or wind speed at eye level should range between 1 to 3 for most fuels and topographic situations. So topography, natural fire breaks, and locations of smoke-sensitive areas may have a bearing on which wind directions are going to be your most favorable. Regardless of wind direction, wind steadiness is very important and should be forecasted to occur throughout the planned burn time. Relative humidity also has a strong influence on fire behavior. It influences moisture content of the vegetation, and as relative humidity decreases, fuels become drier. As relative humidity increases, fuels retain more moisture and are less apt to burn. So for example, for each 20-degree rise in temperature, relative humidity is reduced by about 1/2, and for each 20-degree drop in temperature, relative humidity roughly doubles. The preferred relative humidity for prescribed burning ranges from 40 to 55%. Below 30%, prescribed burning can become dangerous. Fires can be more intense under low humidity ranges, and sparks may be transported outside of the burn area. And then if relative humidity exceeds 55%, the fire may leave some unburned islands and not be hot enough to achieve your desired results. But this also depends a little bit on what your objectives are. So you may actually be searching for a patchier burn, and in that case, having that high end of relative humidity may be what you're looking for. So Again, think about what your objectives are. So you can see here in this image, high relative humidity levels, fuels retain moisture. So temperature can strongly influence the moisture content of the fuels to be burned. High temperatures help dry fuels out quickly. And under most prescribed burn objectives, the air temperature for a late winter to early spring burn should range from 20 to 60 degrees Fahrenheit. But if your objective is to kill woody vegetation, temperatures above 60 degrees may be necessary. The tissue death of plants is around 150 degrees Fahrenheit, so you'll need to raise that tissue in those trees to around there to kill them, and that's a little easier to do when you start out at a higher ambient temperature. Rainfall also has an effect on both fuel and soil moisture, and it's important to have a good idea of how much rain has recently fallen on the area to be burned. Damp soil helps protect those roots of those grasses and forbs and trees you might want to keep. For most prescribed burning objectives, the soil should be damp to moderately wet at the time of the burn. Fuel moisture. The moisture content of fine fuels such as grassy and weedy materials is strongly influenced by relative humidity, temperature, and rainfall. Fine fuel moisture should range between 10 to 20% for optimum burning conditions. If you get below 7%, you can start to damage plant roots, and over 30%, burns will move slowly, could be irregular, resulting in patchy and incomplete burns. You should always check the bottom of the litter layer prior to the burn to make sure that it's damp. Another important factor to consider is air mass stability. Atmospheric stability is the resistance of the atmosphere to vertical movement and has an influence on smoke management, which is important during a prescribed burn. The unstable atmospheric conditions actually promote the rapid smoke dispersion. So it might sound a little bit backwards that you're looking for unstable atmospheric conditions to really promote good smoke dispersion. But some of those indicators of an unstable atmospheric condition are wind gusts, clear skies, and clouds with vertical growth. And some indicators of stable atmospheric conditions where smoke will be held close to the ground and cause problems are poor visibility, layered clouds, and no wind. Topography, or the lay of the land, influences fire behavior, and it's also the most constant of environmental elements. So aspect, slope, and terrain are all elements of topography, and aspect refers to the direction of the slope and determines the amount of heating fuels get from solar radiation. So for example, fuels on a south-facing slope will get more radiation and dry out quicker than fuels on a north-facing slope. Slope is the degree of incline of a hillside. Fires will burn more rapidly uphill than downhill. And if you take a look at the image on the bottom, this is kind of a demonstration of why. Those fuels that are uphill of a fire that's moving uphill are getting preheated and dried out ahead of the fire. And then terrain refers to the shape or lay of the land and can influence the direction and rate of fire spread. So now that we've covered some elements of fire behavior and things that can influence fire behavior, we're going to talk a little bit about planning a prescribed burn. And there are 4 primary components: a regulation review, evaluation of the prospective burn site, preparation of a burn plan for the site, and a pre-burn site and equipment preparation. So the first step in planning should be to review the applicability and requirements of any state, county, and local ordinances that might regulate prescribed burning in your locality. And you can get this information from the county sheriff, local fire department, or county health department. Next is the prospective burn site evaluation. This is preferably done 6 months to a year prior to the intended burn. So you have to evaluate the site for establishing fire breaks, get in contact with the neighbors, figure out your equipment needs, figure out what type of fire is needed depending on the location and your intended objective. You also need to get information about the amount and type of fuels to be burned, both inside and outside the intended burn area. look at the topography and location of property boundaries, and then walk the entire site, make a map of the area, mark locations of things like roads, trails, water bodies, natural fire breaks, any smoke sensitive areas, fences, utility poles that may be running close to the burn site or through the burn site. Next, we're going to prepare the burn plan. So this is an all-inclusive document that includes a description of the burn unit, preparation needs, special concerns, or potential hazards. It'll have information about the firing sequence and a detailed map of the area. Burn plans are there to help the landowners carefully and thoughtfully prepare for the prescribed burn. Information in every burn plan. There should be maps with boundaries of the burn unit, information about the adjacent landowners, topography, indication of where the control lines are, roads, homes, and then instructions for the sequence of fires to be set on those maps. The burn objective should be clearly and precisely stated. There should be a description of the burn unit with the types of fuels, any particular areas of concern or areas that are wet or particularly dry that may change fire behavior within the burn unit, and then a description of adjacent lands with types of fuels and the topography, just so you're aware and prepared for what may happen if there were to be an escape. It's a good idea to know the fuel types and a description of the surrounding area as well. A burn plan should also highlight any areas of special concern in and outside the burn unit. These areas might pose safety, health, or smoke hazards, and there should be measures to mitigate these concerns. For example, snags or cedars in the burn unit, next to the burn unit, and special things that you need to do to kind of mitigate those areas. And then there will be a pre-burn site preparation and checklist. What site preparation will need to be completed before the burn and can be safely conducted. And then equipment needs. List equipment that should be on site at the time of the burn, such as cell phones, water sprayers, rakes, flappers. It's always important to remember to never skimp on equipment. Definitely better to have more than you need than to have be missing something during your burn. So some examples of some equipment that you might have on a prescribed burn would be a slide-in water tank unit, a stainless steel backpack pump sprayer, or an ATV with a sprayer, and of course a handy fire rake and reliable flapper. So personnel needs will also be listed in a burn plan. Everyone that needs to be there to safely and efficiently carry out that prescribed burn. And like equipment, you never want to skimp on personnel needs. And the burn plan should also have a list of people to be contacted, the neighbors, local law enforcement, local fire departments, and these are all good to contact in the planning portion of the burn plan and then the day of the burn. And some local fire departments may even volunteer to come assist the day of. So the next part of the burn plan is the acceptable burning parameters, which is probably where most people will spend most of their time looking. So this is a list of conditions that need to be met at the time of the prescribed burn. And these are in place for safety also, so it's really good to follow the acceptable burning parameters when you're looking at conducting your burn. So the burn plan will have the time of year for the burn. In Indiana, a lot of people tend to burn in that February 1st to April 15th kind of spring burn window, but the time of the year you burn will depend on your objective. Time of the day. It's important to start so you can have everything completed before sunset. So usually we're looking at starting between 10 a.m. and noon. The relative humidity range is between about 40 and 55%. And remember, anything below 30 can be dangerous. And then wind speed. The 20-foot wind speed is ideally between 6 and 18 miles per hour, and the eye level should be between 1 to 3. Temperature range is typically between 20 to 60 degrees Fahrenheit, but again, that can be a little different on the high end, depending on what your burn objectives are. Soil moisture, soil should be damp to moderately wet. Allowable wind direction, only wind directions that will achieve the burn objectives in a safe manner will be allowed. Firing methods, only those firing methods that will achieve the burn objectives will be conducted. And fire escape plan is also very important. It'll be a step-by-step contingency plan and who will do what in case of fire escapes or emergencies and who to contact. So next we'll talk a little bit about establishing control lines. There's a couple different kinds. You have your natural fire breaks, your constructed fire breaks, and then your green crop fire breaks. Natural fire breaks are existing physical features that do not contain any combustibles, so rivers, streams, ponds, roads, things like that. Constructed fire breaks are areas where vegetation either has been completely removed due to tillage, sprayed with water, or frequently mowed to consist of only standing green vegetation. And you have green crop fire breaks, and these utilize a fire-resistant crop such as winter wheat, or clovers that are typically going to be green during that time of the burn period. So this picture here shows an existing physical fire break. So we got the road here running along the right side. This is a picture of fire break established with tillage, getting down to that bare soil. Typically a good rule of thumb for fire breaks is 15 feet wide or 3 times the height of the tallest vegetation, whichever is greater. And this image shows a tilled fire break with a mowed strip. And this can be nice because it can really help your igniter during a prescribed fire, so they're not igniting vegetation that's really tall right up next to them. And these last couple images show green crop fire breaks. This is winter wheat, and this last one is clover. So establishing control lines also involves black lines, and these are created by setting fire to the leeward or downwind portion of a fuel bed, and this allows the fire to slowly advance in a controlled fashion against the wind. So in this image here, this is establishing a black line, and we have the wind moving from the right side. And then the fire is moving slowly into the wind from the left to the right. So now we'll talk a little bit about some different firing techniques. The backing fire is the easiest and safest method, provided wind speed and wind direction remain steady. It's always started along a fire break or other barrier at the most leeward or downwind edge of the burn areas, and allowed to back burn into the wind. So this is the technique that you use to set up those control black lines. And you want to burn an area at least equal in width to the expected average flame height prior to setting any other fires. Generally, this will be about 20 feet. So this image, you can see someone starting one of those backing fires. So the wind is moving from the left to the right, and the fire is moving slowly into the wind from the right to the left. Another technique is the strip head fire, and this employs the use of a backing fire followed by a series of strip fires set in sequential order along lines upwind from the control line and perpendicular to the wind. They are timed so that no strip fire becomes too robust before it meets a downwind fire break or another line of fire and then dissipates. Typically, these are about 20 to 50 feet apart, but this can be adjusted depending on how the fire is behaving and the conditions out in the burn unit. So this diagram here shows the strip head technique. So on the right-hand side, step 1, start the backing fire. Allow to burn windward at least 20 feet. And then step 2, move 20 to 50 feet upwind, ignite a strip of fire across the width of the field here. So the fire on the right side of this line will be moving as a head fire in this direction. The fire on the left side of this line will be backing into the wind. So step 3, when the first strip head has met with the backing fire, move 20 feet upwind and ignite a strip fire across the width of the field. So as you can see, you just keep moving this way until the field is burned. So this is another picture of a strip head fire. So this person here is lighting across between these two burned out sections. So the wind is moving from left to right. And as you can see, this first strip right here is creating this head fire in this direction, and then a backing fire from it in this direction. Flanking fires employ the use of fire set in lines parallel, flanking to the wind. Not recommended for most landowners. And typically these are used along the flanking control lines or those fire breaks that you have already set up to burn vegetation within the burn area away from those control lines, similar to the results you might get from a backing fire. So this is kind of an image of the flanking fire. So same as the previous image, the wind is coming from the left to the right, and this person would have lit this fire straight into the wind this way, and then it'll burn kind of sideways into that unit. So a ring fire creates the hottest fire and is best used when the burn objective is to control woody encroachment. So utilize the backing fire at the downwind edge, and then the remainder of the perimeter will be ignited, starting at each end of that backing fire. You move in the windward direction. You need 2 people to complete this, and ideally the downwind landscape would be primarily bare soil in this situation. So this is an image of someone demonstrating the ring firing technique. So ideally there'd be another person coming in this opposite direction, but he's coming around and completely enclosing that entire burn unit. Another image of ring fire, good for controlling woody vegetation because it gets really hot. And so this last image here is the image of a head fire. So in this image, the wind is moving from right to left across the picture, and this fire is moving with the wind. And as you can see, the flames look pretty intense. It's kind of tall. This fire can be moving pretty quickly. So another diagram here of the flanking fire and head fire techniques, and this also ends up being a ring fire diagram. So start with step 1, get your backing fire and your black line control line in place. And then step 2, simultaneously, 2 people will start flanking fires, moving in the windward direction along the edge. And then step 3, you can start that head fire or close out that ring once these guys have all connected through here. So smoke management is the next thing we're going to talk about, which is a big important part of conducting safe prescribed burns. So it's the responsibility of those conducting a prescribed burn to minimize any detrimental effects that smoke from the fire may cause. If you're conducting a burn, you can be held liable for damages or accidents that occur as a result of smoke from the burn. So consider all on-site and off-site impacts that smoke might have. Use up-to-date weather information, and only burn on days with conditions that allow for smoke to rise and dissipate quickly. And those conditions should be spelled out for you in those acceptable parameters sections of your burn plans. Burning should not be done when wind will carry smoke across roadways, dwellings, or other populated or smoke-sensitive areas. Prior to the actual burn, it's important to start a small test fire involving the fuels to be burned, and that can help you evaluate the smoke behavior, make sure it's doing what you expect, and the fire behavior to make sure it's moving as you would think. Use a backing fire to mitigate smoke whenever possible. Burn during the middle of the day and try to be complete on all of your burns prior to 5 p.m. And you can also consider breaking larger burn units into smaller burn units to help with smoke management. So this image just shows that test fire, again lit in your burn unit with the fuels that you'll be expecting to burn. So you can look at what the smoke is doing and how the fire is behaving and make sure it's doing what you would expect it to do. It's important to notify adjacent landowners, homeowners, local fire department, and local law enforcement agencies several days prior to the burn, and then again on the day of the burn. As part of the actual burn plan, you should prepare an emergency plan that addresses change in smoke management, and always be prepared to extinguish a fire if it's not going according to plan, both for smoke management purposes and if the conditions are not quite what you'd expect or they change on you. So always be prepared to extinguish a fire. And never conduct prescribed burns on organic soils. These fires on organic soils are almost impossible to put out and can continue to burn underground and create smoke problems for days, if not weeks. Another very important part of conducting a prescribed burn is having the appropriate burning apparel. All persons assisting with the burn should be wearing at all times a hard hat, leather gloves, eye protection, leather boots, but not steel toe, and have a handkerchief for covering the mouth and the nose, and fire-resistant clothing that is 100% natural fiber, such as cotton or wool. Don't use clothing that is synthetic because those synthetic blends can end up melting to your skin if they get too hot. So 100% natural fibers. There's also fire-resistant clothing out there for purchase, such as Knox clothing, which some of you might have heard of as well. So here's a couple people in their appropriate burning apparel. These people have, on the left, have Knox clothing on and their hard hats and eye protection, which is always good to have. So ignition sources is the next thing we'll talk about. It's always important to read and follow manufacturer warnings and safety instructions that come with any device that you'll be using. 3 different types of sources, ignition sources, are drip torch, fusees, and signal flares. And by far the most common one that people will use are drip torches with a fuel mixture of 3 parts diesel fuel to 1 part gasoline. And this is a picture of that drip torch. And you can actually acquire these from the Indiana Department of Natural Resources, as well as some other fire material like rakes and flappers and backpack sprayers. So this is the image of a fusee, not really a common one for most landowners to be using. And then in case of emergency on a fire, call 911 or the local fire department. Make sure to move all persons to safety zones, such as your man-made fire breaks, paved gravel or dirt roads, permanent bodies of water, or any area that's already blackened by the fire. And then contact all neighbors that may be potentially affected. And then once the prescribed burn is over, you're going to want to go out there and inspect the area, ask yourself some more questions like, were the fire breaks wide enough and effective? Did I have all the equipment and manpower I needed? Did it go as I expected? Did I get the results that you were looking for? So make a list of these things that you would do differently the next time, or keep that burn plan that you have around so you know what you did and what worked from the first time. It'll be important to return to the site of your burn several times during the growing season to really fully assess the results and see those changes in vegetation diversity and density. So I wanted to end this presentation and talk a little bit more about objectives and thinking about your objectives beforehand and figuring out if your objectives are met at the end. So I have pulled some pictures from Renovating Native Warm Season Grasses for Wildlife, a Landowner's Guide, which is a Purdue Extension publication, just to kind of highlight the differences that you can get in vegetation from different management practices to help figure out your objectives and figure out what can get you those objectives. So this field on the left picture here is dominated by big blue stem and Indian grass, thick, rank native vegetation. And then this picture on the right is the same field, but it's following one March prescribed fire. So that spring burn window that a lot of people burn in. As you can see, the composition of the field has not changed. It's still dominated by those native grasses. Then this picture on the left here, the bottom of the picture where you can see that more bare dirt and the very scattered vegetation, that was sprayed in September and then burned in March. And the top portion of that picture where you can see the more green is the same area as that previous picture that was only burned in March. So you can see that there is a big difference between an area that had an herbicide application first, then a burn, versus just a spring burn. And then the picture on the right is is that same field from the very beginning, following one September prescribed fire. And as you can see, there's been an increase in the forbs compared to just that March prescribed fire, but there's still a lot of really thick native grasses in that field. Then these images, the one on the left is a grass-specific herbicide applied in September, followed by a March fire. Did not really reduce the amount of native grass in the field or increase the amount of forbs. And then on the right, you have a more broad spectrum herbicide applied in September, followed by a March fire that effectively reduced the amount of native grasses in the field and increased the forb number. And then conducting that fire after an herbicide application can also help remove that thatch that you get left over after an herbicide application has been completed. So I hope that was educational for everyone, but if you have any more questions, please don't hesitate to reach out to us and send us a message. And weather permitting, we are actually hoping to conduct this prescribed burn and video record it for you guys, so stay tuned for that as well.